Welcome back. In the previous video, we saw that strings are immutable, and today we are going to look at how we can create a changed version of a DNA sequence using Python's replace method. Suppose I have this DNA sequence ATGCCGTA. Now imagine that I want to change every C into T. If the sequence is very short, I could do this manually, but real DNA sequences can be thousands or millions of characters long. So how can Python perform this replacement for us? The basic idea is very simple. We need to tell Python what we want to find and what we want to put in its place. Here we are finding C and replacing it with T. And when we make those replacements, our original sequence becomes a new modified sequence. And Python has a string method specifically designed for this operation known as replace. The syntax for replace method is sequence.replace old, new. We start with the string we want to work on, that sequence, and then we use dot replace, and inside the parenthesis the first argument old tells Python what we want to find, and the second argument new tells Python what we want to replace it with. So we can read this as take this sequence, find this old value, and replace it with the new value. And this method gives us a new string as a result. Now let's try it with our DNA sequence. First, we are storing our DNA sequence in the variable named as sequence. Now look at this line. New sequence equal to sequence.replace C, T. Here we are calling the replace method on our DNA sequence. The first argument is C, so C is what Python is going to search for. And the second argument is T, so every matching C will be replaced with T. The result returned by replace method is being stored in a new variable named as new underscore sequence. And then we are printing the new sequence. And the output is ATGTTGTA. Our original sequence was ATGCCGTA and it contained two C characters. Python found both of them and replaced both with T, and therefore we get ATGTTGTA. And notice something important. We are creating a new string here. The original string itself isn't being modified. And this is consistent with the fact that Python strings are immutable. There's an important behavior we should remember. Replace method normally replaces all matching occurrences. Our sequence had two C characters, so both were replaced. And this means that if we write replace C, T, Python doesn't just replace the first C and stop. It continues through the string and replaces all matching occurrences. But sometimes we may want to control how many replacements happen. And Python allows us to do that by providing an optional third argument. The syntax can be written as sequence.replace old, new, count. The first argument is still what we want to find, and the second argument is still what we want to replace it with. And here the third argument tells Python how many occurrences to replace, and here the count is 1. So in this case, Python finds the first C, replaces it with T and then stops. And the output is ATGTCGTA. And when we compare that with the original sequence, only the first C changed. The second C is still there. So remember, without a count, all matching occurrences are replaced, but if we provide a count, we can limit the number of replacements. So far, we have replaced individual nucleotides, but replace method can also work with a longer sequence. And here we are writing sequence.replace cc, tt. This time, the old value is not a single character, it's the two character sequence cc. So Python searches for that exact substring, and when it finds cc, it replaces it with tt, and the output is atg tt gta, and our original was atg cc gta. The cc in the middle has become tt, while the rest of the sequence remains unchanged. So replace method isn't limited to replacing one nucleotide, it can replace larger pieces of a string as well. Now it's your turn. We have the DNA sequence ATGACGCA, and our task is to replace every A with G. Now before I run the code, pause for a moment and predict the output. Look at every A in the sequence and mentally replace it with G. Let's check our answer. Our DNA sequence is stored in the variable sequence, and then we are using sequence.replace A, G. A is the old value we are searching for and G is the new value. Since we haven't provided any count, so Python will replace every A it finds. And the output is GTGGCGCG. Let's verify why. Our original sequence is ATGACGCA. There are three A characters and each one of them becomes G, and therefore we get GTGGCGCG. And this is exactly what we predicted. So the important idea is that replace method searches the string for the value we specify and creates a new string with the requested replacements. Now let's summarize. When we want to change part of a DNA string, we can make use of the replace method. The basic syntax is sequence.replace old, new, and by default, Python replaces all matching occurrences. If we want to limit the number of replacements, we can provide a third optional argument, that is count. And because strings are immutable, the replace method gives us a new string rather than modifying the original string. That's it for replace method. In the next video, we'll look at changing the case of DNA sequences using upper and lower method. Thank you for watching, and I'll see you in the next video.